Okay, just a quick background before we start. I think now everybody knows my name, Deepak. I've been in the industry for around 11 years now. Started my career as sysadmin for a year, then support engineer at Red Hat for 3 years. Left Red Hat, joined a startup. We did the cluster development, ported ZFS to Linux, about ZFS hard system of Solaris. Then we ported in Linux, and then few other things. Then again I joined Red Hat 3.5 years back. Then I was doing the benchmarking for them for different products like cluster, storage, cloud, OpenStack, and then OpenShift. So that has been my work area at Red Hat. I'm running Docker Meetup Group in Bangalore for more than 2 years now. And last year I wrote a book on Docker as well. Recently I'm working on a project for Linux Foundation. So we are building a course on EDX to basically help out build managers for the newbies to understand what cloud is and how it is going to shape up. So basically, how does containers and OpenStack works? How does there's basically cloud DevOps and containers works and all those things. So this is going to be launched in June 1st. It's a free course on EDX, so you can all enroll for that, and once you get announced, then you can just go and learn on that. That's kind of another good content. So I'm working on this with one of the. Anyone heard about Cloud Foundry? I'm working with the Cloud Foundry VP of Engineering there. So we both are developing the content for that. So I'll give you the link if you want to sign up right now, or you can just do that as well. So let's get started. I think it's kind of so I left Red Hat 3 months back and doing consulting and training in container technologies. So I did this free workshops in different cities in India. I finished in Bangalore, Chennai, Pune, and Hyderabad, Kolkata today, and then last one in Delhi. There would be a virtual workshop. I'll do one and then kind of finish on the free workshop session. I get it once and then maybe again we start a few months down the line. But I do offer paid trainings for 2 days, which is a much more content than whatever we cover today in more detail, more hands-on. So I'll give you a bird's eye view of everything today, that how things are looking from a top level. How does the container is going to change the entire things the way we used to develop and all that. I'll give you about this introduction with very hands-on, and we'll go and look at the how things are going to work together and how it changes the workflow for developers, ops, and the QA guys that we'll see, but on top level. But let's get started. So everybody know VM, right? Everybody would have some kind of VM. So basically, like in VM, so basically, let's say our endpoint is always to run an application. That application can be run on. So for an application, we have to install like in a VM. So if we take the host OS and then we install some hypervisor, So we install some hypervisor on that, and in that hypervisor then we install guest OS, and in that we install whatever the libraries and then the app. Think about for an application to go outside of the host machine, right? It has multiple hops, right? First of all, anybody have heard about the user space, kernel space, right? So basically, first this is the user space of the VM, right? Then this is the user space, the kernel space of the VM. The hypervisor is again the kernel space. Then you have the kernel space of the VM, the host machine, and then you go out. Correct? There are multiple hops on which an application would basically go and outside the world. So this is the whatever things we have been using. We have a long time that all we are aware of that thing. But if our end goal has always been to just run an application, right? Now we can take this application, and this application if we can kind of take this application we take and give it all it needs to do the communication with the external world, and give its own identity that okay, this application now is an independent entity which can talk to the outside world, which will have its own host name, which can have its own mount space, paid namespace and all that. Then this application can work as a VM, you can say. Correct? So that is what the containers are. So basically you take this application, and with this honest application you give it everything what it needs. We'll talk about more on that. And run on the host OS directly. So basically, rather than running an entire VM to run an application, we take that application and give it what needs to behave like a VM in very simple terms, and run on the host OS. So now there are no hops what you have seen here, right? First, user space to kernel space of the guest OS, then guest OS will go to hypervisor, hypervisor will go to host kernel and go out. The application is there, this application is just give what it needs and just go out on the host machine itself. Make sense? Any questions till now?
Yeah. So would that improve performance?
Of course, definitely.
So boot time and stuff.
Boot time would definitely get increased. Other than that, there are other things, right? So basically, first of all, density, right?
I have one question. In the standard VM, we have the guest OS. Guest OS can be different. One can be Linux,
Correct.
Windows, and all.
Yes.
And the host has got only one OS.
Yeah.
So what happens here?
Yeah. So kernel. So then that's it. So basically, on containers, you need to have this compatibility here. Host OS and that's your compatibility. Like you cannot say I'm going to take a Windows application and run on Linux.
Okay, so here like application A can be on Linux guest OS, application B can be on Windows guest OS.
Correct.
What happens there?
Yeah. So in this case, it's a limitation. The limitation is that if one kind of app would run on one kernel itself. Basically,
So you have a common host OS which is the applications are running.
yes, so basically, rather than on the host OS per se, I would say, yes, I'll come to that. But just think about you cannot run Windows or Linux, just in terms of that right now. But if like if you are scaling, like if talking about running thousands of containers or fund application in the data center, you would not worry about this thing. So basically, you can take another Windows OS and not even Windows containers, right? Rather than running on Windows, rather than the compatibility, you would basically just do a different guest OS, host OS, and run on top of that. So first of all, density increases because you don't have to do any emulation here. So in this, here you need to do emulation, right? You need to say how much RAM I want to give, how much CPU I want to give, and all that, right? You need to have the emulation here. But here there is no emulation required because everything running on the host.
So then latency should decrease, right, sir?
Latency
should decrease.
Yes, performance increase. Latency decrease means performance increase. Correct. Basically, your overall working would be very fast, right? Make sense?
One question. So when we are doing in VM, we allot, say we have apps ABC, we allot like hard disk and RAM space to each of the apps, like however we.
Correct.
What is the scenario when it comes to?
Yes, so here you can also say that how much RAM do you want, how much CPU do you want, and all that is there. The basic idea is clear, right? That what are the difference between containers and the VM? Okay, this is clear. Now, okay, one biggest thing before I move forward. So for application to run, it just needs libraries, right? So think about your application, right? Your application just needs the libraries to run. It doesn't need any kernel component to run. correct? What happens is when you, let's say you are trying to do any, let's say you try to open a file in Linux, right? So what would happen is you would have some kind of place to open up something like that. You say I want to open this file, whatever this file is, and you go to the, say I want to open this file, it would go and do a read or write call, right? Whatever you have said. Then you would have a glibc layer, right? Glibc layer. The glibc layer would basically move you from user space to kernel space. Now it would go to the file system. Then it would go to the hard disk or whatever. Then it will go to the correct sector. We'll get that file and give it back to you. But for an application, the interface is glibc. Right? For application, the interface is glibc. It doesn't have to worry about anything with the kernel, right? So what you have to do is basically when you are running the containers, you have to make sure that the corresponding libraries with it. You don't need to have a kernel component per se, but you need to have libraries what it needs to be run for an application. So what do you pack in your container? You pack in the container your application plus the libraries what it needs to run. Think about you want to run an application or Python program which runs on Python 2.7, but your host machine is Python 3.0. So what you would do if you want to run Python 2.7 or Python 3.0 host machine, you would basically take a stack, install Python 2.7 on that, and put an application on that, and give the stack as a container to your host machine. So even your host machine is Python 3.0, you don't have to worry about all that, because you are giving all this environment as a box to run on the host machine, which is all dependency. So for once this goes out, it will go the glibc will go out to the kernel and all that. So you take the application, give it dependency, and then do it. Make sense? This is how the difference between the kernel and this is the difference between the can we just say?
Yeah, yes, on that.
Right, so basically this is the main difference between the VMs and the containers. Okay. Now how does it work actually? So Linux specifically has these two kernel features called namespaces and the C groups. So namespace are one which gives you to do the isolation, resource isolation, and C groups would give you resource allocation. So basically, what would happen is if you let me show you some example and then we'll do this thing. So currently I'm currently on a machine which has Docker installed and all that, right? So don't worry about all the commands that are running right now, but just be with me. So okay, before that, so if I do a top command here, so if I do PSAUX, you would see there are a lot of processes are running right on this machine, correct? Now I'm going to start a container. Now if I do PSAUX, I would just do process here. Correct? So this is running inside the container. So what has happened is we had a machine which has a lot of processes. Then we got a container. Then the container we started on busybox, whatever, and then we did the PS. Or basically look at the folder what you are running this. So you just see that two processes only, right? One this bash and whatever we are running AUX or whatever. So what has happened is we have created a container, and in the container we have given it a PID namespace. That means that application can now have its own PID namespace. That can work as a process namespace. So it would have its own process namespace. It would have its own host name. So if I do a hostname command, hopefully it works here. You would see the hostname is different, right? Something CMU or whatever. And if I come out of this, and if I run host name again, this will give you a host name of the machine on which I am running. So what happens is, these are the namespace which is responsible to do those things. So whenever you take an application, and that application you would say, this is my namespace for quit, for mount namespace and all that. That's you get different entity. C groups are used to give your resource allocation. So basically if you want to say, I want to give my resource of container as 512 MB of RAM, I want to allocate a specific CPU to my container. That is because of the kernel feature of C groups. Now these are the features of the Linux kernel itself, which has been there in Linux kernel for like 10 years now, or more than that. So basically what happens is in this case is your Linux kernel is responsible of providing these things. So there was something called LXC. How many of you heard about LXC? LXC is Linux containers, which are a long process, mean for like long while. But to basically run a container with LXC is like, it requires you to do a lot of things manually. So basically when you take an application, you say, okay, now I want to put a jail on that. Now I want to give a namespace of IP address, all of those things. So containers have been there for a long time, but they were not very usable. Usable says like it's not very user friendly. They're usable but not user friendly. If you want to start a container, you do a lot of those things manually, step by step. So now, what Docker did is basically Docker made these things very easy for you. So we just say Docker runs some other command to just do all things in background for you. So in the background you can just do all of those things. So basically if you just say Docker and one command, Docker and busybox or something, right? Because of that, all the magic happened in the background. You don't worry about how does namespace getting allocated, how does C group getting allocated and all that. That happens in the background for you in a single command. And that's when containers became very popular for the last 2-3 years because they become very usable. So now, how do you access these kernel features? There are different interfaces. So basically you have libraries to access the kernel features. So now Docker developed lib container. And these are other ways to access these features. Either you can use Docker or something else. But you have to use kernel features. Docker hasn't developed any of these as a company. What they did is just write a nice wrapper around that, which looks like very easy. So now, what if Docker does is Docker talks to the lib container library. Now this can basically fork to other interrelated windows. So they build common libraries through which, depending on the OS, it will fork out. So now container server is also coming in Windows. So if there is a Docker run command or whatever Windows thing, it would go talk to the container and figure out okay, underlying is Windows. It will go some other magic into background. For Linux, it will come to Linux kernel, use these main features to do the containerization of the things. Any questions?
So, do Docker really work on Linux?
As of now, but there is support going to come on Windows pretty soon, which they are working on. Besides, the lib container is going to fork out these things.
Yet you are using a Mac there.
Sorry?
You are using a Mac.
Yeah, but Mac is, so with Mac I was starting a VM on Linux. But it's eventually a Linux machine on which I am showing. Any other question? Then we can look down the line. So these are different Linux features which I talked about namespaces, right? So namespace is like PID, which will give you different PID PIDs. Net would give you different network address. IPC would give you different enterprise communication channel between the containers. MIT would be different mount namespace, like how do you mount your programs, what is your root directory and all that. UTS would give you different host name. So you can have different host name for the container also. User would give you like this user address is being used for basically the root on the host machine is not the root in the container. So basically if you have given a container someone, the container's root is not the root of the root user of the host machine. So if somebody you set the container as a root, you do some nasty things will not affect the host machine. This is for that particular for resource allocation, C groups are there. So basically, if you look at your, if you are doing less machine right now, if you go to cd/proc sys fs So if you see your sys fsc groups, you would find different control groups running on your machine, on the LS machine. These C groups will basically say that how you are going to allocate memory to a given process or given container. So containers are nothing but a process. They would run as a process on the host machine. So even though you are saying you are going to start a container, which effectively means you are starting a new process on the host machine. So they are not something which you like a hardware machine and all that. What you would just do is you start a new process in the host machine and give it with the namespace, you give them whatever it needs. So effectively a process on the host machine and you run the containers. And to allocate a certain resource to a process, you would use like different kind of control groups. Like there are control groups like for CPU accounting, like how much block I/O my process can do, how much CPU I can allocate to a process, and all that is part of the C group and how do you define them. So yeah.
So is there any way to allocate all those resources automatically?
Yeah, that's what happens. So basically, when you start a new process, essentially you fork a process, right? When you do a fork call in the kernel, right? So by default, whatever the process for the root user, for the parent will go to the child. If you want to chase something, you can chase something. That's how it works. Okay, the other interesting thing about, okay, let me see if I can show that there. So whenever you copy or write, simply means that you use the copy until you don't want to write on something. So think about this, your parent-child thing. So when you do a fork inside the Linux kernel, you don't create a new entity for the child process until you don't need it. Other use case is mmap, and you do mmap call Linux kernel, call Linux user space. You do a memory copy of the things. Another thing you can think about is, anyone know what snapshotting?
Yeah.
What does snapshots means?
Yeah, regular backups.
So basically what you can do is you can make you can basically say, okay, this is my disk. I want to take the snapshot of this, basically like you take a picture of that. Right? But now let's say you have taken you have written like 4 blocks, you taken the snapshot of the entire things. Now, this will be remembered, let's say there is a pointer which is referring to this particular thing, whatever. But now you just want to change this thing, right, on some other thing. So what you would do in that case, you would basically, when you want to change something, but this is a snapshot which is already being referred by S1. But if you want to now modify something, so what you would do is, until you don't need it, you just use this block as it is. Think about this, you are doing a lot of reads, right? For a lot of reads, you will not modify these things. But as you kind of change something, what you would do is make a new copy of it and change whatever you want. and different was a new pointer like S2 and different like this. But until you don't need a change, you just prefer the same thing. And when you want to change something, you copy it and then write it. It's called copy on write. So basically, you don't modify something and you don't have to, right?
So does it take up extra space to save the new snapshot?
Does
So
it?
in the case of S2,
Yeah.
when this snapshot happening on write, would there be usage of space?
Yeah, there would be basically then, but you don't need it until you don't have to. You can use the refer the older one as it is. So they kind of refer a pointer by pointers, like what is my array looks like, kind of go and do different like that. But if you just want to change something, you have to change, you will copy it and then do that. Okay, now why it makes sense in case of containers? So what happens is when I did in the Docker, so basically we already did a BusyBox image right on our laptop, my original laptop, right? So now this BusyBox is the base image. Now we can start. What happens when I did Docker run one command, right? What that happened is that created a writable image, writable layer. And that writable layer which you can do write or read something. So I did the Docker run command, right? Docker run command something, right? What that did is it created a writable layer on that. Now what I can do is if I want to start 10 different containers, at the same time what I'm going to do is I'm going to defer the same base image. But I'm going to create 10 different layers like this in parallel. So in this case, I'm always going to use the same base image. For the new container what I create, I'm going to just create this writable layer. Make sense? That's how it works. So basically when I am going to start, let's say 100 containers, my base image is going to be the same. So I don't have to worry about this image. This image is as intact as it has to be. No change in that. But whenever I do, I will make a new layer and just do on that. Make sense?
What is the use of creating a new writable layer? Is it for?
No, it is think about running your application, right? You do some changing some file on that, right? You want to make some modifications. Let's say you got the base image. So basically, let's say I got. Okay, let me do this. What I do is basically let's start on the container. Right? I have this host name. I change host name minus n. Whatever F. So if I change this thing, right? I don't know why it's something to do with the BusyBox image per se. But okay, let's do some other way. Let's just create a new file here. In this I'm building a date command, putting the output into some file. This file is the output, right? Okay. Now what I do is I'm going to come out of it. I'm just saying Control D. Now I start again. Now should I say the same file there or not? Okay. Whatever the file is in there, right? Should be there or not?
No, no.
Should not be there, right? So what happens is because we got this BusyBox, so I went to the where Docker and I did the ls, this is the typical ls. I got these things. Now if you go to the container folder, so I need to do a root. I went to the container, I would see that for the container, for each container I have some IDs. So when I create the container, right, for each container there would be a folder created in the where lib Docker folder. Let's look at the last ID what I had. So I think I remember something like that. So if I go in the folder of that particular, if I do ls there, if I go to the specific container folder, you would see that some files are here. And some files are here, which basically are information about the container. Okay. Now you did the Docker logs, right? With the logs command, right? For the logs, there would be a log file. So what happens is for each container is popping out, it's spitting the information in the JSON format in varlib Docker folder. But when we run the Docker logs command, it basically goes and reads this file and shows you out.
So the file structure over there, it's similar to some kind of MVC framework, right?
Some kind of
MVC framework, Ruby on Rails or PHP stuff.
it's a no
Generic stuff.
it is generic. It's common for everything.
So does it mean you can run some MVC on that?
No, I have no clue. No, I don't think it's given that. So what you can do basically, you go to varlib Docker folder, varlib Docker containers and container folders. You will find all the information about the container. Let's look at the config file. Let's see if you look at the config file. You would see that for the containers, it's putting on information like what command you have been running, or the arguments you have given, and all this information. So basically, it's like it gives you what the container is supposed to do. For the container information at that point of time. It's running right now. Running is true, false, whatever it is, right? So for each container, what is the state of that being saved in the config file, right? So now this is the root way of saying it. What I can also do is I can just come and say Docker ps. I can also say Docker inspect and the container ID. Then also give all the information in a JSON format. So I can get the information about the container in this format. Docker inspect and give me all the information what I can get about the container. What is running right now, what is the IP address and all that. Now I can do like this. Like I can just say grep for IP address. I can just say grep, give me only the IP address. Give me like whatever the IP is saying, it's find out what the IP of the container. Have you phrased the Docker inspect command, Docker inspect and the container ID? It works for you, everyone. Which one? Docker inspect command, inspect. Docker inspect container ID. So you basically get the container ID. Docker ps and do inspect of that particular ID. Docker inspect of the ID. Work? Anybody is fine with this point of time? Yeah, you can look down the line. I want to skip it right now. I'll not do it. So if you just want to list the ID of the container, we just say Docker ps minus aq. Aq means just give me the a minus all. Q give me only the ID. Just with the IDs. Now what you can do is you can give this thing command to the, let's say, if I want to stop all the containers, what I would say is Docker to read all the containers. I would say Docker ps minus a minus q. It gave me all the IDs. I want to stop all of them. I would say Docker stop Docker ps minus aq. I will take the IDs of my one and stop all of them. I can remove them also.
So what is the difference between minus a and minus q? You said minus a.
Minus a just give me everything. Minus 2 will be only the IDs.
Only the IDs, okay.
And I can now pause on a command and I can just follow that command as it's
Stop puts everything.
So it is just
This is stop state here. You can start the container also. If a container is a stop state, you can say Docker start also. If any container stops speaking, it's Docker start out.
Freelancing, it's a great word.
I can do Docker start, remove the container, I will run Docker rn command.
So you should be connecting wherever.
This would remove all the containers. I would not have any container running. All of them are gone now. Because I ran that command, right? rn. Okay? There are more of them there in dual links link down the line later on. So there is one option called privilege. With the privilege mode, you can run the containers in a privilege mode. Privilege mode means that it can give you more access, more permission to do more operations. So let's say if you want to mount a disk or whatever, those operations are not available by default to you. But if you use privilege option, you can do more things. Like if you want to run TCP dump on the TCP right now. Think about you want to do some extra than typical operation. You specify privilege option right now. Just think about it simple now. You specify privilege option, you can do some operation which is not available by default if you start this container. This start containers. Does anybody have Nginx container with you? Nginx with you? Nginx image with you? You have Docker pull Nginx right now. Docker pull Nginx. Nginx will take some time, but that's okay for time being. So Docker images. I have Nginx. So if you see if you can download Docker pull Nginx. This will download the Nginx image on a laptop. Okay. Now Nginx. What does Nginx do? It is a web server, right? Now let me start a container Docker run Nginx. So see, I haven't specified any option here, right? Then what it's doing is currently running on the terminal itself.
You did not mention
Any options, right?
in dash or
Yeah, so yeah, that's one thing. Other than I haven't specified in an option also, right? In run also I haven't given anything option. I haven't done anything. It just says Docker run. So what I will do just right now is I will kill it right now. And I give now Docker run minus I minus d, that's it. So I got the idea of it, right? Now what I will do is I get the IP address of this container Docker inspect, get the IP of the container. I can specify 65. I don't specify the entire ID because until it matches the unique name, it will just give me the information about that. I'm just saying that IP. So I got the IP of the container is 172.17.0.2. Okay. Now just do the correct test on that. For 170.17.0.2. So it's working now. I can say that it's working. Okay.
how did it get an IP address?
So what?
How did that image got an IP address?
Now there is a container of the IP address on the image.
Yeah.
And I did Docker run, right? It gave a container. Now the container is on namespace, right? The Nginx got the IP address now because it has the facility to get that for the namespace. So we just
After running this, when you ran Docker inspect, you did not give any ID.
I gave 65 only. I can specify any ID. So just get the ID. So basically,
First two numbers.
yeah, it will work.
Okay.
As a unique thing, it will work. Until as a unique, it will work. Work for you? You got the current thing, you can do this thing, right? We'll just wait for you. But you get the curl, right? Not for you, but for other people, you get the curl output, right? Okay. So now what the current setup looks like is, it is like this. On my laptop, how it is, I have the host machine. In the host machine, I have a VM, a Linux VM. So my host is Mac. In the Mac, I have a Linux machine. Then I have a container in there. And right where there is 170 whatever bit to make it right. Now let's say you want to access the web page from my Mac. So I have to go through like this, right? I have to go through my Mac, I'll go this way and then the container, right?
Can you repeat, sir?
If I want to access the home page of the Nginx of the container from my Mac, I have to first go to my Linux VM and then only I can access it, right? Then I can do it. Until everybody got this idea, right? So now, let me get my IP address of my container or the machine. So if I get IP here, so my IP address of my VM is this. Now if I go and open it on the terminal, it fades. It does not open it, right? Now what I do is, I get a new Nginx container, but at this point of time what I specify here is -p 80:80. What does this mean is, I am saying that now, so 80 port is by default in the Nginx container is there. What I am saying is 80 is, I am saying that open up port 80 here and map this port 80 to this container
In my machine.
on the VM.
On the VM.
So basically, according to my setup, or according to your setup also, because we are running a Linux VM. So I am saying that open this 80 port of the host machine, where I run Docker daemon, and map it to the 80 port of the container. This is what this command is saying. Now if I do this thing, now if I go back to the browser, it works.
This is the IP of the Mac.
No, my VM, let's see, open Mac.
First is the internal, first one is the Mac port and the next one is the internal.
Not the Mac port, VM, Linux VM.
Sorry, first one is the VM port and the next one is the internal.
Correct, correct. Now,
What happens? Just one question. What happens if I directly use the IP of the Docker container?
that will work inside the VM. I cannot access the outside. Not here seen earlier, right? If we don't map this port 80, right, then I can access the web page only until here on the Linux VM. I want to access on my Mac thing. So see if I stop it, right? If I say Docker stop CC, my container is stopped now. Now if I go and do it again, it will fail because my 80 port is not mapped down. Make sense? Clear?
So when you say mapping the port, you mean port forward?
Yes. Okay, is this clear? Now how many of such thing I can do for 80 port or those? I can only one, right? Because Linux VM would have only 180 ports to be mapped. Now if I want to start another container, right? But I can again say port 81 now mapped. Let's say 80888900. Now port 8900 of the. Now what happened is I created a new container here, and now I am saying that map 8900 of the Linux VM to the container. Make sense? Now if I go and appear on the terminal or the browser and I say 8900, I'll get it again. But this is a different container.
So since you have run two commands, so port 80 is also mapped and 8900 is
Yes,
also mapped.
with different containers.
Okay, right.
Not different.
They are different. One container here is 8080, is 8900 to 80.
Okay, that is the other one.
Yes, so basically now you can start n number of containers and you can map, but it will map to different IP address, different port number of the host machine. Now if you don't want to remember what port I want to give, you can just now give no nothing here, just say :8. This will also start. This will also start. Now you can say I am starting like how many containers? I can start any container with very quick time, right? Because I have the same base image, I can just the top layer to do that, right?
So over here, which port is getting mapped
Yeah.
to the thing?
So I'll just see now. Now what you would see here, in this case, there would be a random port from the host to get back to the port 80. Rather than giving a specific port number, I can just say this thing and I can just map now. Now I can click any of this time I will go to a different container and different container would serve different engines. Now you can see I am running 10 or 8, whatever number of containers, and they are all running up web traffic. Is clear? Any magic looks like this magic, right? Like you can now n number of servers, quick time. Like while loop and just like starting up. That's how the containers are going to change the way we deploy things.
Okay, just one question. I mean, if we start multiple number of containers, are they using the same RAM and processor, or everything is different for each of the containers?
They are different for them because they have different schedules. But you can currently they are not using much of it, right? But they have currently they can go up to anything. They can borrow some one container stops using 5 GB or whatever. It will start until clear. It will get all the RAM. Until you specify how much I want to give. With -m option here, when I start this -m Docker and -m 512, the container will only 512 MB.
So one thing is, I like the Nginx server which is started. I mean, that was not, it did not start properly, so I was not able to get the join. So I have again started this Docker run Nginx. But this thing is there.
Now minus D.
Now minus D.
Docker minus D. Docker runs minus D. Nginx.
This will start another.
Yes.
So there are two running right now.
So one is the soft check one. I usually running now in the background. Docker inspect and container ID.
So there are two that are running. So one is this one.
One is Docker PS.
So this is the one. This is the background one that is also running.
Yeah, we have go in the background. Now inspect one. Docker inspect. File. Do the minus 3 now. Again, minus 3.
hardware. Circuit board,
Now, we have some containers already running in this mode, right? Now let's say if you want to go inside a container, right, which is already running. So there's another command called docker exec. We will start with the other command inside already running container. I give the same option like what I do for the run command, docker exec, and I can take any ID here. And I can say bash. So what happened is I have gone in the container now. So let's say I start the container in the background or whatever, I want to know what's the container on, check what's happening there. I can do docker exec -i -t or 1i -t and give the the container and the bash. So I can go inside ordinary container and see what it's doing.
So when you do that, will the other containers be paused or?
No, they're not. It's like running a new process in a container. So if I do now PS, you would see what option taken is the parent also PPID. So what's happening now? I got a new bash command which will be parent of this, child of this command. So I can now go and check what's happening in the container. Now, with exec command you can start a new process to it. Okay, everybody still here? Can see what's happening? Okay, should we move on?
So what's the difference between AUX and AUXA? Same?
No, nothing different. There's first kind of command difference. I was thinking if I can check the parent ID also.
Okay.
There's some signal option. Anyway, this was not there. Everybody's clear? Fine?
Yes, sir.
Fine? I'm going to kill all of them. I'm going to kill all of them. So I got. So if I do this RM or not stop container, I will see me error. I will say minus F would go and forcefully stop all of them. Now start on the container with now let's say Ubuntu Docker run minus D minus IDD Ubuntu bash everybody is here. This is very important. You can't miss this thing. You have to basically have this thing there. Everybody is here to this point. Okay? Yeah, everything will be there. Fine? Okay, now what we do is we do exec into that Docker exec minus IP, give the ID what you have, and again do bash, again the container, get there. Whatever name you have, 5C is for my name, whatever name you are getting. Okay, everything there. Now create a file here, whatever you want to create. You want to write anything, just write that. Again, 2 files are in that thing, right? I have 3 files I have created now, right? Okay. So anything you want to create, just take create some file what you want to create in there. Don't you worry about it. Everybody has some files there. Okay? Everybody has some files. Okay? Now I'm going to come out of it, Control D. Now out of the container. Okay? Now what I'm going to do is I'm going to, so what will happen is I have the base image and I have the writable layer, right? The writable I created is files. Now I'm going to commit the writable layer to disk. So by default that layer goes off if you don't do anything. Now I want to save that layer to disk. So what I will do is Docker, I'm going to Docker commit minus M whatever name I want to give. Let's say committing whatever. I will specify the container which you want to commit. So my container ID is 5C, right? And I'm going to give a name. I need to give a name with minus T option, and I give a same like mcurry / my image. What has happened is I got my new layer very quickly. So I did Docker commit minus M some name or basically whatever you want to give, ID, and the name what you want to give to the new image. Have you done that? Last command. I will change the container name whatever you have and the name what you want to give.
What it did?
Yeah, it is. Run this thing. If you run this thing, just run it. I'll go to GitHub, create a repository here. create new repository. Okay. Everybody has a GitHub repository in the name and the Docker Hub created. You can account Docker Hub and GitHub. If you already have GitHub in your repository. Create state that you want to give. Okay, you get something like this. Create on readme to basically create a new file. Just click on readme and write something on this. Convert this new file. So you'll get something. Now here you go and click on new file. New file, give a name, Docker file, write something, whatever we did earlier. Just for the time being, just say something like some very specific thing. I'll just say that. Okay, everybody has a Docker file. Comment it. So you got a new repository with whatever name you have and whatever repository name you have given. Okay. Now go to Docker Hub. And Docker Hub. Go and click on create automated builds, second option. Go to Docker Hub. You will see a create option in the login form. Say create automated builds. Click on that. If you haven't, so then now you need to kind of, here you would have option to create, sync up with GitHub. You would see an option like that, right? For me, it's already there, if I'm not seeing there, but you would see an option like link with GitHub. Click on that. Have you done that? Please do so as doing that. Link with GitHub. Whatever organization you have. In this, I would click on Kolkata. And I do a create. Everybody is clear? Okay? Be required. Done? So everybody got this thing set up? So I will bring it. Okay? Got it? Now go back to the Git repository, what we had. Added the Docker file. Let's say we say hello Kolkata. Put some exclamation mark here and save it.
What did you change?
Something, whatever you do. Something. I did the commit here, right? Whatever you did the commit here. Now what would happen when you did this commit? There is going to be a new build get triggered on the Git repository. So whatever you had, right? So now I say building, right? So what happens in this case, you can do this automated builds for a Git repository. Basically, you can link your Git repository with Docker Hub. So whenever you make any changes in your Git repository, by default you will get a new image created here. And now I can use any image like this now I can just Docker pull enter this Kolkata. Now with that image you will contain Ubuntu what is in handling. Similar thing for you also, whatever you have done. So basically this will kind of help you out to basically make an automated build for your codes. Basically if you want to share your builds every time, you basically configure your Git repository, put Docker file in that, and link the Docker file with the Docker Hub. Whenever you do a commit in the Docker Hub to GitHub, automatically a trigger would happen here and you get the latest image for your code. Now, this image can be used with you or anyone. So rather than say that three ways of sharing, right? You make a tar file, you share with your user. You make a Docker file, give it to the user, or you push your code or the image on the Docker Hub. Now anybody can use from here. Docker pull, this thing will get it.
I have coded this between latest issuing tag as well.
Sorry?
Now currently this is the last latest one.
Yes.
So tomorrow I do another. Does this tag change automatically?
And you can change, you can give a different tag also.
No. If I do something tomorrow, that will be the latest.
Yes.
What happens to this tag?
This image would be I think somewhere down the some tag, you have to give the tag
I
here.
have to change the tag.
I think so.
Because then both will be showing as latest.
No. Well, there will be one latest. Whatever the latest code have pushed, whatever the latest image, that's the only latest.
So what happens to it? This tag changes automatically, you have to change it.
No, I think it will be the latest only, I think. If you want to build older one, you change the code in the GitHub and you trigger become the latest one. Okay, so it would basically, what would happen is eventually success right now. Now I can just say Docker pull enter in Kolkata, I should get whatever I had. Or I can now give it to anyone and say, like, if you want to use my code, just Docker pull and use it. Make sense? Now search Docker file instructions. So you would get
I'm sorry, I'm having one problem. I've linked this GitHub with this Docker Hub, but somehow I'm not able to see that Docker file which I created here.
So did you hit the commit there? You have to make some changes first.
Here.
Yeah, you need to change this file. Then only you will trigger it.
Otherwise, I won't see it here.
No, otherwise not trigger the new build. Go with this Docker file, change some random changes. So now if you look at the doc,
Even after committing a change, it will trigger the build.
what's happening? Is this saying something? Well, it might take some time because this is not a free account, right? So this is the free account, they will schedule it as you go. If you are paid, there will be more priority. But the idea that yes, as you linked it, the Docker file is Docker file, capital D, UC, file, you would do that. It will take some time.
Yeah, now it is showing.
Not sure. You right, yeah. So it will take some time because this is a free account. So the free account, they might have just 1 or 2 bits and they'll give priority to the paid users. So that's why whatever scheduling they have. So they are different. And if you look at the Docker file reference, right, you would see what are the options you can give here. Like you can say run command, VFC, you can give environment variables, you can give like these are the things, right? And copy, so if you want to copy some files from local machine to the Docker file, you can use add and copy commands to basically say copy. So basically, say you have some custom file which you want to run as a install process. So you can now say add and copy. So basically, make the copy locally, and then while building, you will say add a copy, look at copy inside. There are other things like you can put some key value pair, key labeling store. You can specify expose. The way we set up 80 port, right? So if you look at the Nginx Docker file, so go and search for Fedora Docker files on the internet. Fedora Docker files. There would be lots of Docker file examples are here. Depending on your application, what you are doing, you can select how you are going to basically, you can create your own Docker file for different applications. Now let's look here for Nginx, what we have used. So look at Nginx Docker file. You would find that it is an option called expose 80. Because we said expose 80, that's why we, by default when we are running the Nginx thing, we are getting port 80 as the expose port from the container. So this is how we specify. In the, if you recall, in Nginx we did not specify the command to run, right? So basically in the Docker file of the Nginx, there is an option called CMD. So with this option, basically what it means that whenever you stop the container, stop this command by default. That's how you basically when you build a Docker file, you can specify what command should I run by default. Because we will specify bin bash, right? So this is the by default command would run. That means whenever you say docker -d and the image name, it is going to start get the Nginx image and set the container with this command. That means start with the Nginx daemon itself. So this is how you can specify what should be run by default when your image starts, container starts. Okay. Let's take some time and try to look at some examples here. There are multiple examples in this federal Docker files. Just browse through some of them. So one I would definitely can maybe give you an example of let's say WordPress. Now see what's happening in WordPress. We are getting the latest WordPress and all whatever it is, but we are running a command called scripts sh, right? And here there would be an add button, add. So what we are saying is start building the image, right? You copy this folder from local. So basically if you see the back, there would be a script folder. So say take the script folder, copy it, in the image what is created, and then whatever the volume will cover right now, and CMD this command should run to start the WordPress.
This is an example of a Docker which will run WordPress.
You can just basically say Docker, take this Docker, so basically you can clone this particular repository, go to WordPress folder and just Docker build it. Should start WordPress for you, just like that. Not worrying about everything. Now let's look at the script folder. So we'll find some interesting file here in this particular sort of thing. So what happens is there are two ways to do things. Basically when trying to say I want to start WordPress, it will require some web component and database component. That means you want to run two different things in one container. So, but by default, container supports to start only one process. When you start container, it is meant to be you are starting only one process. But in the background, what you want to start database and web together. So what we start here is something called supervisor as a top level process. So when we say start of FS program, it's going to start a program called supervisor D. It is going to manage two different services, web and D. Just like we start top. Top runs two of them. That's how it works. That's one way of doing it. Other way of doing it is basically this clear, right? Why we are doing this? Because WordPress would have two components, right? So one way is like you just start two services in one container, but that's not supported. You should have only one program. We didn't have a father program, a parent program. They will start two childs, web and D. That's what this particular code is about. So you can just check out on your time when you get time. But the idea is clear, right? Okay? One way of that is we run the them in same container. The other thing is what we can do is we can run web and DB to different containers and then link them together. Linking means that they can refer each other by some names. So let's see. Now what I'm going to start one container and I'm going to say refer other container by some name. Some other container. So let's say I'm going to say run. You can all say, so I'm just using let's say again Ubuntu image. But I can give a name here like database. So I'm saying give it in a name is equal to DB. So this is the name I'm giving to the starting container and I'm going to start Ubuntu. So what I'm saying here, start the container, name DB, but from start Ubuntu, just for the name's sake. Okay? So when I do this thing, I would get a container, or I would get a container with the name DB. So the last one is the names, not the last one is the name, and I'm referring this container as a DB. Okay? Now what I do is I start another container, I name it as web. Okay? Now I'm going to say minus name DB colon database. What I'm saying here is make a new container name web and link to the DB container what you get earlier as database. That means inside the web container I can refer DB container and database name. So what I'm going to say, I want to remove the D option from here and I would go inside the container. Okay. Now what I can do is I can say ping database. So what I can do is basically I can build my web and DB in different containers, but link one to each other. So when I'm writing my program or when I'm writing my application, and I can refer whatever is being given in the WordPress configuration, saying to my other container refer them by this name.
One thing, why do you remove D minus I?
I want to go inside the container. By D,
You want to go inside the container.
Yeah.
And DB colon database, what is the database?
Yeah, that's also basically I'm saying that the other container what has a DB name, right?
Yes.
So refer that DB container to database in this container. So now see I can just do ping database, right?
Okay, so that container, the new container will refer to the other one
As database. So when you are creating a program or writing a code, you can write like that. From other container, refer them by this name. How does it happen? Because the linking thing, what happens is you get a new entry in the etc host file, and they get referred to like this. Whatever. See, IP address of the previous container is referred like this. So basically, rather than waiting on the IP address, because I would not have the IP address information of the DB container in the web container just like that. I have to somehow get it. I'm going to link like this.
Okay, so can we link by creating a container or can we do it afterwards?
No, just create the container. Because on this case, because otherwise this entry will not populate automatically. You can do it if you want to start, you start afterwards, but you have to make the entry manually. What happens also is that if you look at the environment variables, they also get okay, because we haven't done that. Fine, this makes sense as of now. So if you have actually exposed some port on the other container, right, this port name would also come here because we haven't exported any port there. So basically, let's say if you have a database container, right, the database would expose MySQL 3306, something like that. So now by default, entry of that 3306 will also come here. It will like database port is equal to 3306. So whatever exposed post on the export port on the previous container, they will also come here as a environment variable. And those also can refer in the program like that. Rather than giving a specific port number, you can say database underscore port. And that we can refer something like that. This makes sense?
Sir, is that version of WordPress fully functional? As in a PHP server?
So currently we have not done it. If you take the Docker file from there, it would work as it is. Yeah.
Let's say you want to write a plugin for that. Should you change your syntax while writing to be compatible with dock stations? What do you call this, sir? Dockerology.
What?
This thing.
Nothing. Docker doesn't have to worry about
Docker.
that.
Yeah, not Docker.
It has to be just like as it is, as you are doing it, should work as it is. So, this makes sense. Any questions here? Now, the interesting thing what happens is this is what we will do on your one machine. You are going to easily do that. Okay, but very okay. Let's follow for the time being. So now let's just come out of it. Now let's just see. I want to again remove all my containers. Okay. Now what do you see is if I do IPA command gives me IP space A command gives me that IP addresses of different interfaces on that machine. So in my machine, at my VM, I am seeing multiple interfaces, right? And you would see there is a special called Docker 0, right? Now what is the use of Docker 0? So what happens is what happens is, okay, let's say the typical case, let's say these are our few machines in the internet or the local LAN, right? These would be attached to some switch, right? There would be some switch, what we have, and they would be all linking like this, right? So one guy can reach to other guy by this link, right? Or it goes, right? Now, if you see this is a LAN cable. Suppose this LAN cable has two ends, right? One end point is at the container, and one at the host machine, the LAN cable, the LAN whatever you have, and one at the switch cable. So this is the LAN cable what we have, right? So now when you start the container, so when you have one machine, right? On that one machine, this is my let's say host machine, whatever host, I start multiple containers. Now, how this container would link to each other? There should be something called some kind of switch. So what happens? You create this switch and link each other container like this. This is Docker 0. So when you start Docker daemon, it would create this virtual entity for you and this expander. So as you create more containers, this would create new entity, and this would go through your LAN point, whatever you have, like ETS 0, whatever you have, and go to the outside world. So what happens? Every container would go to Docker 0 and will go then out. Okay? So what you are seeing here is Docker 0, right? So what? So this is like when you say W0, ETS 0, ETH 1, and Docker 0, right? Now let's start a container and see what happens.
So instead of linking to containers, we can also use Docker 0 to connect to containers.
Whatever is happening Docker 0 only. Containers are going to Docker 0.
And it's the both way communication.
Yeah. So now I'm starting a new container. Right? Now, if I again do IPA, you would see that I got a new entry here, right? This is new entry, correct? And in the container, I refer dbin, right? Now what I am doing is Docker exec db and IPA command. So what I did here is I did the exec into the container what I had, and then the IP one came out. Now you would see this is ETS 0, right? On the container. This is how it happens. So basically when you create a new container would get an ETS 0 interface, and your host or container host Docker 0 would get a BTH something. So whenever you create a new container, a logical or kind of virtual entry get created which links your container with this thing, and that's how you want to contact each other, right? Is this clear? Make sense? Anybody have any questions here? No?
One question over here. is the new something you have written below the Docker zero switch?
This was VTH.
Yeah. What is that?
VTH pair. So this is nothing but this logical link is called VTH pair. So basically, if I do IP right, you see this VTH pair.
Okay.
This VTH and the radius will get linked together.
This is outside the container.
This is on the host machine.
On the host machine.
And this is on the VTH on the container.
Inside the container.
This is the logical entity what we have.
Okay.
Okay?
That VT is connected to Docker 0.
This is a Docker 0 bridge, right? And you got a new container, you will get a new port like this. This would get something like VETH 0, whatever. And it would have another end of the new container with ETH 0. So if I start a new container, right? Let's say here. Now I expand my this thing here. This would have a new pair. This is called VTH something. And it's called ETH 0 anything. Okay? It's clear? Now let's look at more magic. Now, what I'm doing is I'm going to get a new container. At this point of time, I'm going to say minus IP. But I'm going to say minus net is equal to host. What does this mean? So basically, we talked about namespace earlier, right? Namespaces. You recall, right? Now, with that namespace, what happens is host, whatever the VM, whatever you have, that would also have different namespaces. It's not a single container and namespace. All the OS also has a namespace by default of its own. So a host also would have by itself net namespace, pit namespace, UTS namespace and all that. So your host machine also have a namespace. Now with this term what we are saying is that you start the new container, but when you start the new container DB1, don't create network namespace, rather use the network namespace of the host. That is, we can share the namespace also between the machines. What does this mean is when you start the container, this container would get the IP addresses of the host machine also itself. Basically, we are reaching this container by the host IP also. So let's see the logic. So basically, now I'm saying I create a new container on a Docker exit DB1 IPA. Generally, what would see ETS is something like that, right? But here you would see the entire thing. For this container, you would see entire what you see on the host. So this is like your host is container saying the same namespace of the host. Can you think about any use case of this? What is the use case of this thing you can think of this feature? Do you think any use case would be there or no?
Two containers sharing the same IP but using different ports, like services, right?
Yeah, that's the different use case, not this use case. This is a use case of a very specific thing. Think about is you install a base machine, right? Base machine has whatever like RHEL 7 or whatever you have, right? Now we don't want to install any package on that. Let's say you want to install MySQL on that, but you don't want to put any footprint of the MySQL in the machine. So what you would do is install Docker, and Docker you would install a container of MySQL with this option, that is equal to host. Then what would happen is your container would start and you would get particular version of MySQL running here. Next time if the new version of MySQL comes in, you don't have to worry